Scientific notation, section 4-4. Scientific notation can get very complicated. It's a nice way to condense your numbers, but it does get confusing, so please pay attention. Scientific notation, the number one rule, one non-zero digit to the left of the decimal times 10 to a power. Only one place value can be to the left of the decimal, and it cannot be a zero. 3.12 times 10 to the sixth power. Proper place value etiquette. Decimals at the end of a whole number are usually invisible. 14.0 equals 14. Or 14 point, nobody writes that, 14 decimal equals 14. It is truncated, you remove it. Decimals at the beginning need a placeholder. 0.13 equals 0.13. It holds that decimal in place so you don't lose it. Decimals are really tiny. We need to keep track of them. Invisible decimals must be put back in at the end of a whole number before you begin scientific notation. Conversions. Let's take scientific notation to standard form with a positive exponent. 3.12 times 10 to the sixth power. This is scientific notation. This is a positive exponent. Positive exponent means move the decimal to the right or multiply by 1,000. An exponent of 6 means 6 zeros. Exponent of 6 means 6 place values to the right. So here's my decimal right after the 3. I can count 1, 2, 3, 4, 5, 6. Place my new decimal. Now go in and put in my commas. 3,120 or 3,120,000. I'm so sorry. 6 place values. Now it's in standard form. Notice the difference. Scientific notation, standard form. What if I have scientific notation to standard form with a negative exponent? Well, when we had a positive exponent, we moved to the right. And when we have a negative exponent, we're going to move our decimal to the left. A negative exponent means to move the decimal to the left. Negative 6 means 6 spaces. So 1, 2, 3, 4, 5, 6 place values to the left. This would be the same as dividing by 1 million because you would have it in the denominator because it was a negative exponent. We're taking some shortcuts here, and we are just moving our place value. I have to put a placeholder there, so I have 0.0000312. You always add a 0 in front of a decimal as a placeholder. Notice that I now have 6 zeros, even though one of them is in front of the decimal. Standard. So what if I start with standard notation, standard form, my actual answer, and I want to create scientific notation? Well, I say, where is my decimal? The original decimal was invisible, and it was at the end of the whole number. It was here at the end of the 9. I move it so that there is only one non-zero digit to the left of the decimal. So what I need to do is underline my first non-zero digit. I then know I'm going to move my decimal right behind it. How many spaces? 1, 2, 3, 4, 5, 6 spaces. So I have 7.826459 times 10 to the 6th. My last decision is that 6 a positive exponent or a negative exponent? Well, when you move the decimal from the right, it means it's a positive exponent. I also know that this number was a nice big positive whole number, which leads me to believe it's going to be positive. But the best way to know if you did it right, check your work by converting back to standard form. If I have a positive 6, it means move my decimal to the right. I am going to get 7,826,459. I get my original standard form back. So I know that I have done it correctly and I've used the correct exponent. Well, what if I start with a decimal? That immediately in my mind says, uh-oh, I've got a value here less than 1, probably going to need a negative exponent. I can't tell you this will be every time because there could be some whole numbers included, but this is the standard practice. So I need to look for my first non-zero digit, 6. Normally I would underline the first non-zero digit. I move my decimal 1, 2, 3, 4 to the right. 0.381. So I have 6.381 times 10 to the 4th. I need to decide, should that 4 be positive or should it be negative? Well, my decimal was moved from the left, which tells me negative. In my mind, though, I can see that I started with a decimal already, and that tells me it'll probably be negative. Check your work. 6.381 times 10 to the negative 4 means move the decimal 4 spaces to the left, fill it in with zeros, and yes, I have my original standard form back. This is confusing. Take your time with it. Do not rush through this, please. What if your standard form has a decimal? So now I start with a value that's not a whole number. There's a decimal in it. Just because there's a decimal already does not mean that it is in scientific notation. This is still standard form because there is no power of 10 and you don't have a 1 digit to the left of the decimal. Underline the first non-zero digit, 4, on the left and insert the new decimal. Count your spaces from the old decimal. That number of spaces is going to equal your exponent, and rewrite it in scientific notation. 4.31276 times 10. I moved it 3 spaces, 3. Now determine if that 3 should be positive or negative. The original decimal was on the right, so it is positive. But check your work to make sure that you have the correct answer. Here are some examples. 9.2 times 10 to the 3rd power. This tells me to move my decimal 3 spaces to the right. I end up with 9,200. Empty spaces are filled in with zeros. Add commas when you're in standard form. 5.24 times 10 to the 4th, move it to the right, 4 spaces. Replace all these empties with zeros. Add your commas. The decimals become invisible in standard form because they were at the end of the whole number. 6.7 times 10 to the negative 5, negative exponent, move it to the left, spot 5 spaces to the left, replace all those empty spaces with zeros, and now add your placeholder at the beginning. Now it is written in standard form, your answer. There is no power of 10, so this is standard form. That means convert it to scientific notation. Underline the first non-zero digit on the left. Move the decimal to the right of it. 8.2 times 10, I moved it 4 spaces from the left negative exponent. Check your work to make sure. 8.2 times 10 to the negative fourth, move the decimal 4 to the left, and I get my original standard form here. Take a look at it. Make sure you understand. And of course, you have the option to watch this video several times to make sure you understand scientific notation. One more slide. 4,362. This is a whole number. That means the decimal is invisible at the end. Put in your decimal. Underline my first non-zero digit. Move my decimal. I'm moving it to the left, but it started on the right. This is where it's going to get confusing. You're going to want to make it a negative, but it's not. This is a big whole number. You're going to want a positive exponent. 3 spaces. 4.362 times 10 to the third power. Should it be a positive 3 or a negative 3? This is the big question. Well, you have to check your work to make sure you did it right. If I use a positive 3, that means move it 3 to the right. Do I get my original? Yes, I do. So I have it correct. Scientific notation is not easy. I suggest that you go over this several times. Bye now.